All right, welcome to the 4.4 notes. This is how to solve the system of equations by using your calculator. So in this packet, we're looking at the same thing we've been looking at in class, but we're looking at kind of the technology side. So the tool that we're going to use on the calculator is called a matrix, kind of like the movie. And a matrix is a rectangular array of numbers. What that means is that it looks like a square or a rectangular set of numbers, and we can describe this set as having dimensions 2 by 2. Okay, because here we have 2 rows and 2 columns. So we would say that this is a 2 by 2 matrix. In the next one, we're looking at another matrix. It's kind of a rectangle or a rectangular array of numbers. This one has 3 rows and 4 columns, so we would say that this is a 3 by 4 matrix. I'm going to explain a little bit more of the vocabulary in a second here. This last matrix, again, it's a rectangular array of numbers. It's a rectangle filled with numbers. Those numbers happen to be variables here. So each of these variables can represent a number. And here this would be a 2 by 3 matrix. So the numbers that are aligned horizontally, each one of these horizontal sets of numbers is called a row. Just like in a table, we call this a row. And then the vertically aligned numbers are called columns. So I'll label it in 2 different matrices so you can see which ones I'm talking about. Across is a row and down is a column. All right. Each of the numbers in a matrix, so each of these numbers here are called an element. So in this first matrix, the elements would be 1, 0, 0, 1. Here, 2, 1, 3, 1. Each number is an element. Okay, and then the size that we were saying, the 2 by 2, 3 by 4, 2 by 3, those are called the dimensions of a matrix. It tells me how big the matrix is that I'm talking about. All right, so how do matrices help us with systems of equations? Well, we can take a system of equations, and as long as it's in standard form, we can convert it into a matrix. So this is kind of our x column, y column, and equals column, and we are doing just the coefficients into the matrix. So the elements of the matrix come from the coefficients of our equations. This means that each equation is represented into the row of the matrix. So the row of the matrix rows of the matrix correspond to the equations in the system. Both of the equations in the system, notice, as I mentioned, are in standard form. If they're not in standard form, we need to write them in standard form first. And the coefficients of each variable are placed to the left of the line. So this side is for the coefficients of the variables, and then the constants go on the right-hand side. The coefficients go into each of the columns for their respective variable. We wouldn't want to switch x, y, and then y, x. We want to make sure all of the coefficients of x are in one column, all of the coefficients of y are in a different column. All right, let's take a look at the example. All right, so I want to write example 1 as a matrix. That means I have 2 equations, I need 2 rows, and I'm only listing the coefficients. So as a guide, I could put an x and a y here as just kind of a reminder. They're not part of the matrix, but they're a good way to set up my matrix. And I'm putting the coefficients of x in the first column, so 2 and 6. The second column is my coefficients of y, which are 5 and 1. And then my last column is my constants, 8 and 10. So here I have my matrix. 2, 5, 8, 6, 1, 10. Okay, and remember, x and y are not part of my matrix. They're just a tool to help me guide and make sure I'm putting the correct coefficients in the correct column. All right, pause the video, try example 2, and then when you resume the video, you can check your answer against what I write. All right, so here I'm going to put my guiding variables x and y, but now also I have a variable z, so I'll make another column for z, and lastly my equals column. Coefficients of x are 1, -2, and 1, 3 equations, so I'll have 3 rows. My coefficients of y are 2. There's no y. If there's no y, that means its coefficient is 0, like we talked about when we were looking at the lines x equals a number and y equals a number. We can also write those as with 0 coefficients. And lastly, my coefficient of y is 3. And then we look at the coefficients of z. So I have 1, 2, and -2. And then the constants, 2, 5, -8. Okay, and again, x, y, and z are not part of the matrix. They're just a tool that we're using to help us write our matrix. Okay, go ahead and try the concept check. Again, pause the video and then check your answer. So we need to first write these in standard form. So I need x and y to be on the same side of the equal sign. You should get 6x plus 5y equals 4. And for this one, we should have 2x minus 10y equals -1. Or -2x plus 10y equals 1. If you have opposite signs for each of mine, it's the same equation. All right, so if I'm looking at this, I want an x and a y, 6, 5, 4, 6, 5, 4, 6, 5, 4, 6, 6, 5, 4. So these are in the wrong order, and this one has a negative. So it has to be C, but we should double check our second row as well. 2, -10, -1, or remember I said all of the signs could be switched. This is the same as -2x plus 10y equals 1, -2, 10, 1. So we're looking for the matrix with the correct numbers in the correct order, and sometimes we have to rewrite our standard form a little bit to make sure that they match. But these two statements have to be equivalent. All right, let's look at the next page. The top of this page is just a guide kind of showing you where some of the keys that we're going to use are. So I'm going to move on to the steps, but remember you can always refer back to this picture as you're looking for a specific key to press. All right, so in the steps below, using matrices on a TI-84. Now, this is the calculator that we request for all incoming students, so freshmen and sophomores should all have a TI-84. If you're an upperclassman, you weren't required to have a TI-84, but that is the calculator that we use as kind of our base model. So if you have a different model, your instructions might be a little bit different, but you should be looking for the same keywords. Okay, so let's look at this system that they gave us. Notice it's already in standard form. So I want to put this into the matrix. So my first step is to find the matrix key on my calculator. I'm going to go ahead and switch screens to my calculator and read along the steps while looking at the calculator. All right, so step 1 when we're looking at our calculator is to access the matrix features. So on the calculator, you're going to go to the second button, that's like shift, and then down 3 buttons is you'll see an x to the -1 or the inverse key, and above it, it says matrix. So we do second and that inverse key to get into the matrix menu. And then we want to go over to where it says edit, which means we hit the right button twice. Right arrow. And notice how here I have a list of potential matrices and none of them say anything next to them. That means that right now my matrices are all empty. So I'm going to choose to edit matrix A. So I hit enter. And the first thing it asks for are the dimensions. So what size matrix do I want? So in the packet, the example that we're looking at has 3 equations. That means that I need 3 rows. And then I hit enter. And if I have 3 rows and I have 3 variables, then I need 3 columns plus 1 for my constants. Remember, the equal sign is also a column. So I need 4 columns, 3 rows and 4 columns. Then when I hit enter, notice now I will have an appropriately sized matrix. Now, depending on your calculator, you may only be able to see the first 3 rows, and you may have to use your arrows to get over to the 4th row. That's fine. All right, so first we're starting in that first cell that's highlighted. So the coefficient in my first equation of x is 1. And then I hit enter, and in my first equation, my next row should be y. So my coefficient of y is 3. Enter. And then the coefficient of z is 1. Enter. That last column is for my constants, my equals 5. Enter. And then I have negative 3. Whoops, I did minus 3. I need negative 3. Enter. 1. Enter. Negative 3. Enter. 5. Enter. And now I'm looking at my last equation. Coefficient of x is 1. Coefficient of y is 2. Coefficient of z is negative 2. And remember, I'm using negative and not minus. And lastly, my last constant, my last equal is 9. Now, once I hit enter, it will move me back into that first cell. But now that I have all of my information into the matrix, I want to leave. I want to exit. So to exit, see this little blue quit? I want to do second to get up to the blue, and then mode, which is quit. Okay, so now I'm back to my home screen. The calculator now has the information of the matrix that I want to use. Okay, so what we just completed, we completed step 1, step 2, step 3, and step 4, and step 5. All right, so that was how to create our matrix. Now that our matrix is created, I want to reduce the matrix. Now, what reducing the matrix does is it's going to do a bunch of operations on this matrix, such as the steps that we use when we're doing the process of elimination, and it's going to give me back a new matrix that I can interpret as a solution. So how do I get this magic matrix? Again, I need to go into the matrix menu. So second, the inverse key which says matrix above it. But this time, I don't want to edit my matrix. I want to use my matrix. I want to do math with my matrix. So we hit the right arrow only one time so that math is highlighted. And we are going to scroll down this list until we find the operation called rref. Not just ref, but rref. What that means, it's the reduced reference matrix. It means it's reduced as much as possible. And then we hit enter. And then we have to tell it which matrix to use. So go back into the matrix menu, second matrix. Now matrix A is the one that we entered, so that's the one that we want to use. So we hit enter and end parentheses. So now when I hit enter on my calculation screen, it's going to give me the reduced reference matrix of matrix A. So by hitting enter, it gives me this solution matrix. Now what does that mean? Well, remember how my first column was x? So this tells me that 1x plus 0y plus 0z equals 1. So x equals 1. My next row tells me that y equals 2, and my last row tells me that z equals negative 2. So x is 1, y is 2, and z is negative 2. All right, so by using our calculator, we have just solved a system in 3 variables. And it did take some work of getting to know where the buttons are, but as you get more used to this, solving 3 variable systems becomes much easier. Now, is this useful for 2 variable systems? It could be, but it might be faster to do it by hand. So this will work for both 2 variable and 3 variable systems. Okay, so going back to our packet, as we were looking at on the calculator, this row was x, y, z, or the columns rather were x, y, and z, and equals. So the first row gave us our x value, the second row gave us our y value, and the last row gave us our z value, giving us the solution 1, 2, negative 2. All right, for the try this, I want you to go through those same steps that were written on the last page. Follow along with the video if you want to rewind and rewatch as I go through it. And I'm going to give you just the solution. I want you to be able to create these steps on your own, so it would be a good idea to try solving this without watching the video again. And then if you need to, go back and rewatch the steps. All right. You should be able to do this on your own without notes by the time that you've finished this lesson. So go ahead and pause the video, and the solution will magically appear when you resume the video. All right, so you should get the solution 1, -1, 3. If you have questions on that, you can come into my office hours, you can rewatch the video, follow those same steps with this new system of equations to create your new matrix, reduce that matrix, and then you should get your solution from interpreting that matrix. All right, so let's look at the concept check. What we've seen so far are matrices that give us one solution, our solution being A, B, C. But what happens if I have no solution or infinite solutions? Well, if we're looking at our second example here, we could have a matrix that reduces to our X equals A, our Y equals B, and then 0 equals 0. Well, this bottom row means that 0 equals 0, which is true. That means that there are infinite solutions. Just like before, we cannot write all real numbers. However, just like with our two variable equations, our infinite solutions is a set of ordered now triples because we have 3 variables such that, and then we would just include one of our equations. All right. And then we have here a matrix that gives us our X value is A, our Y value is B, and this last row gives me that 0 equals 1. Well, that's false. And therefore we have no solutions. Okay, so just like with our 2 variables or our 3 variables by hand, we do have the case of infinite solutions and no solutions still. Let's take a look at that last page. Okay, so these last 2, we know that we can do them by hand because we've seen this already in previous sections. However, I want you to try doing them on the calculator, okay? Pause the video. When you resume, I will show you both the matrix that you should have typed in, the reduced matrix, and the solution. Make sure you pause the video. All right, here's part A, the matrix that we get directly from the system, the matrix that we solve, and the solution. If you got your resulting matrix in a decimal, remember you can always do math frac to turn your answer from a decimal into a fraction. All right, now pause the video for part B. All right, so for part B, our reduced matrix gives us a false statement, and so we have no solution. Make sure if you have questions to look over the video, write your summary statement, and you can always come into office hours or email me for questions. That's it for 4.4. Make sure that you do the Math Excel for homework. Now you can always use matrices to solve unless the directions say to show me something by hand.